Hey guys, today we're going to be talking about Chapter 6, Lesson 3. We're going to be talking about multiplying decimals by whole numbers. Okay, so I just included a little picture over here to kind of show the only difference. Like there's no difference at all, except at the end we worry about our decimal point. So let's jump right in and get to some examples. All right, here we have example 1. It's telling us to find the area of a rectangular board that is 4 feet by 3 and 62/100 feet. So if I was drawing this out, it is 4 feet by 3 and 62/100 feet. So to find the area, we know we need to multiply length times width. So if I'm saying 4 times 3 and 62/100, that would mean, if I was going to do repeated addition, as I'm just going to add 3 and 62/100 4 times. Okay, so if I do that, 2, 4, 6, 8. 4 6s are worth 24. Bring my decimal straight down. 4 3s are worth 12, plus 2 more is 14, and 48/100. So if I was doing repeated addition, like that's fine if we're doing low numbers, but man, if we're doing high numbers, we need multiplication. So to multiply it, we are going to multiply it the same way as if it were whole numbers, right? The decimal doesn't change a whole lot. It's still just a number. It's not like there's all these crazy rules. There's one little thing we got to do at the end, but so anyways, if we multiplied like normal, we'd do 4 times 2 is 8. 4 times 6 is 24. 4 times 3 is 12, plus 2 more is 14. Now, what we did is we looked at our number 3 and 62/100 and 4. We said, hey, look at this. 2 digits to the right of the decimal point, right? 4 doesn't have any digits to the right of the decimal point. So there are 2 places to the right of the decimal point, which means I need to count 2 decimal places from the right to left in the product. So I need to go 1, 2. Okay, because there were 2 up top, I need to bring it back 2 spots. Now in this case it lines up, but it's not always going to line up. So you can't just say, oh, I just have to bring it down. It doesn't work that way. I need to count 1, 2 digits to the right of the decimal place in my factors, so I bring it back 2 in my product. The answer is the same whether you use repeated addition or multiplication, so that means we have a reasonable answer. Check. Okay, so here we're going to find 3 times 96/100. So if I was going to estimate, I'd say, hey, 96/100 is about 1. 3 times 1, my answer should be about 3. Now let's go ahead and multiply through. 3 times 6 is 18. 3 times 9 is 27. Plus 1 more is 28. Okay. 3 times 0 is 0, but then I have to add 2. So I get 2. Now I count 1, 2 digits to the right of the decimal. So I bring it back 1, 2 places, and then I can put my decimal point there. So 3 times 96/100 is 2 and 88/100. So the product, 2 and 88/100 is close to the estimate of 3 that we made earlier. So our answer is reasonable. And that estimate took us how long? Like no time at all, right? 3 times 1? That's easy. So very nice. Here we go. Let's do another. 5/10 times 6. 5/10 times 6, okay? So first I'm going to do 5 times 6, that's 30. 6 times 0 is 0, plus 3 is 3. We got 1 digit, so I bring it back 1 place value, and there's my answer. This answer is really just 3. I don't need to put 3.0, right? I can put as many zeros after this, doesn't change it, so I might as well just save myself some time and put 3. Okay, let's do the next one. 2 and 6/10. 2 and 6/10 times 4. 6 times 4 is 24. 4 times 2 is 8, plus 2 more is 10. Oh, we're supposed to check for reasonableness. We'll come back and do that. So I got 10 and 4/10. So let's check for reasonableness for this one. 2 and 6/10 is about 3, let's say. 3 times 4 is 12. Are they close to each other, 10 and 12? Yeah, they are. Okay, let's come up here. So really, you guys, 5/10 is the same as 1/2. So if I said, hey guys, what is half of 6? If I cut 6 in half, what would I get? You'd tell me 3, right? So my estimate would be 3. And our answer was 3. So, well, that's because I didn't really do any rounding, did I? I did just 0.5, 5/10, right? 5/10 is the same as 1/2. I don't know. Otherwise, I could just do 1 times 6, right? And say it's about 6. 3 and 6 are pretty close together. Okay, let's do some more. 4 times 7 is 28. 4 times 1 is 4, plus 2 more is 6. I got 1 digit here, so I need to bring it back 1 digit. So my answer is 6 and 8/10. Check for reasonableness. 1 and 7/10 is about 2. 2 times 4 is 8. Is 8 close to 6 and 8/10? That's basically 7, right? And so 7 and 8 are close. I wanted to do one like this so I can show you how to set it up. So we notice this 3 and 6/10 has 2 digits, 8 has 1. So we want to put the least amount of digits on the bottom. So I should do 3 and 6/10 times 8. 6 and 8 is 48. 8 and 3 is 24, plus 4 more is 28. So that's normal multiplication. I did nothing different. But then I need to go back and I say, okay, I have 1 digit to the right of the decimal. So I need to bring my decimal back 1 place. I start all the way at the right and bring it back 1 spot. So my answer is 28 and 8/10. Let's do one more here. 5 and 1/10 times 7. Oh, let's do our quick estimate. 4 times 8 is 32. 32 and 28 and 8/10. Pretty darn close if you ask me. All right, here we have 7 times 1 is 7. 7 times 5 is 35. Notice I have 1 digit to the right of the decimal. Let's bring that on back. I'm left with 35 and 7/10. Let's do a quick check of 5 times 7. 35 and 35 and 5, 7/10. Pretty darn close. All right, I just want to do one like this so you know what to do when you get to it. This is just multiplying, right? We're trying to find the unknown or the product. So we just have to multiply. Again, notice 3 digits to this 1 digit. Let's put the 3 digits on top. 0 and 33/100 times 2. Here we go. 2 times 3, 6. 2 times 3, 6. 2 times 0, 0. Okay, now I got to count how many digits to the right of the decimal. 1, 2. Bring it back. 1, 2. So my answer is 66/100. Which kind of makes sense, right? If you ask yourself, if I take 33/100 and I double it, I get 66/100. Makes sense, right? All right, that's all I have for you today. Thanks for watching, and I'll see you tomorrow. Thanks for, make sure you ask me any questions that you have. I'm happy to help. Bye.